Hello, my name is Jake Walker. I am in the 8th grade at West Middle School. Math is one of my favorite subjects, and my teacher, Mr. Hutcherson, really helps me understand how math can be applied to almost anything. I have a passion for robotics, and for my Math Moves You project, I will tell you why this is such an interesting subject and why I am so excited about it. For the last 3 decades, robots have been mainly developed by computer scientists and engineers. But there are many problems remaining that require modern mathematical knowledge. Members of the scientific community are beginning to recognize the need to bring math into the development of robots. Real-world applications of intelligent machines involve scientific, mathematical, and engineering problems with large, practical, theoretical, and economic interest. The main goal of current robotics research is the creation of physical machines with similar or beyond levels of human perception, physical capability, intelligence, and behavior. In some areas, such as computer-aided surgery, human capabilities can be exceeded. Industrial robots and computer vision involve a $2.8 billion industry in the U.S. In certain applications, such as automobile painting, welding, and electronic assembly, robots are common. Underwater robots have led to amazing discoveries, such as the Titanic exploration. Robots will extend human capabilities in many other hazardous areas. The field of computer-integrated surgery, or CIS, and medical robotics is ready for growth. Robotics can widely impact quality of life, serving as assistance to the elderly or disabled. Researchers are discovering how to create robots that can coexist with their owners, which will completely change the standard for caregiving. Robotics will also play an important role in future efforts to upgrade and maintain U.S. infrastructure. Intelligent transportation systems will increase on crowded highways. 2 million miles of underground piping are in need of inspection and repair. A lot of that is only accessible by robots. Thousands of crumbling bridges and nuclear and chemical pollution sites must be repaired and cleaned up. The obvious mechanisms for doing this are robots. There are 2 technologies emerging that will have a huge impact on future robots and change the way that we think about robotics. First, advances in microelectronic mechanical systems, or nanobots, will enable inexpensive and distributed sensing and activation. Second, advances in biomaterials and biotech will enable new materials that will allow us to build friendlier robots that can be implanted in humans, and robots that can be used to manipulate, control, and repair cells and tissue. There is a tradition of mathematicians working with roboticists. Many problems in robotics have attracted mathematicians to the field. As early as the 19th century, mathematicians were drawn to the dynamics of machines. While robotics will clearly benefit from an effort to bring greater and closer collaboration, mathematics will also be positively affected by greater interaction. The needs of robotics will suggest new directions for mathematics research. Communications between mathematicians and roboticists will affect the questions asked and the answers that are given. If we do not create and care for an environment where mathematicians and roboticists work together to solve basic problems, society will not likely get the full benefits that the robotics technology can potentially offer. So now that you know more about robots than you ever wanted, you may be asking yourself, how does this relate to my passion? This year, for the first time, my school participated in a competitive program called Smart Move. I was chosen by my technology department to help build and program a robot. We entered a competition that judged the design, construction, and performance of our student-built robot. During this process, the robot was given instructions that relied on coordinates. This was very labor-intensive and was really nothing more than trial and error. The robot would be given instructions to move 6 inches forward and then turn 90 degrees and then move 3 inches forward. If that didn't put the robot where we wanted it, we would try again with different instructions. Of course, this example is simplified, but you get the point. Why couldn't these instructions be reduced to geometric and algebraic equations that simply require that the variables be changed? There is an area of mathematics that deals with this specific problem. I had never heard of this until I became involved in robotics. I don't know very much about it, but now I have a practical reason to learn. Thank you for considering me for this scholarship opportunity, and I hope that this video presentation has showed you how math puts the action in my passion.